Hey, welcome back to SN Tutors. Today we're talking about Diels-Alder. So there are two things you have in this reaction, two starting materials. You have a diene that always looks like this conformation. And you have a dienophile, which is a double bond, usually with an electron withdrawing group attached. In this case, let's make it just a carbonyl. So we have this, and then usually here you could have some groups that are attached, basically. The ones that are pointing in we'll call I groups. Those are in groups. And then out groups, I'll just put OU, just so I'll spell it out completely, so you don't mistake it for an oxygen. But yeah, these are in, yeah, we'll just spell it out. So we have out groups and in groups. So what happens, I'm going to show you the mechanism first, and then I'll show you the stereochemical selectivity. So first we have to go ahead and assign partial charges. So this is electron withdrawing right here. So this has this resonance where it can go up here, right? So that would give this carbon right here a partial positive charge, which would mean relative to that, this is the partial negative. And then this, here's what we'll do. We'll put an OH group right here, which is electron donating. And that would lead to resonance, making this a partial minus, correct? So let me just get rid of those arrows real quick. So we've determined that this is the partial minus, which means process of elimination, this is the partial positive. So what you want to do is you always want to line up your negatives with your positives. So what's going to happen is we actually need to flip this. So I'll go ahead and do that real quick. I'll make it bigger. Here we go. So for flipping it, it'll essentially look exactly the same, except the OH will be here. So just imagine me flipping this over. So that would make the OH here. So now this is the partial positive, and this is the partial negative, right? So it's matched up, positive with negative, negative with positive. That's always how you want to do it. So this is what the arrows look like. The first thing that's going to happen is we show the negative carbon taking these pi electrons and attacking the positive carbon on the diene, and this goes here, and then this negative carbon on the diene attacks the dienophile. So we have this sort of cyclic or cyclo curved arrow structure, whatever you want to call it. So then we get this 6-membered ring as our final product with this attached. So basically you get two enantiomers with Diels-Alder, but what I'm going to do is just pick a random, I'm just going to pick the EWG to be on a wedge. You could pick it to be on a wedge or a dash, and then everything about the other substituents is relative to that. So what always happens is that the out groups are always going to be on the same side as the EWG. Okay, so that means that if this is on a wedge, that means the out groups, here I'll just do, so this is O for out, and then I would be on the opposite side. I should spell it out here. Okay, so outs are on the same side as the EWGs, and the ins are on the opposite side. Now, if we had, let's say, like a methyl group on the other end, right here, then that methyl group would have to be here on a dash in the product because of the fact that it's trans in the starting material to the EWG. So that's basically how you do that. And then obviously there's a double bond there. Sorry, almost forgot about that. And there's no stereochem here. Well, it's not chiral, so yeah, there's no chiral stereochem here. So yeah, that's the final product, and that shows you the selectivity in terms of the stereochemistry, and it shows you the curved arrows over there. And please let me know if you have any questions. Thanks for watching.